Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and we are on to the topic of change of order of integration. In the previous videos, we have seen the problems on change of order of integration and how to implement the concept and how to compute the value of integral. All the things we have found. Now we will have one more problem on the same concept where you are given with I is equal to integral 0 to a integral x cube by a to 2a minus x xy into dy dx, which is in the correct form, which we can already notice that it is in the correct form since the inner limit is corresponding to x and the inner variable of integration is corresponding to y. Now since it is in the correct form, we will be writing the limits. What are the x limits? X is equal to 0 to a. What are the y limits? Y is equal to x squared by a to 2a minus x. So what is this? Y is equal to 2a minus x. It is nothing but x squared is equal to this is y is equal to 2a minus x is, on putting x is equal to 0, we have y is equal to 2. If x is equal to 1, y is equal to 1. X is equal to 2, y is equal to 0. We are just going to plot this and find it to be a line. We are just going to do it in a graph. So firstly, we will notice that the inner limit corresponds to y. Therefore, it is a vertical strip. So, what is this line 2a minus x? On plotting all the points here and joining, we will be having a line here. And this is an upward parabola, as you all know. So, what will be the area of integration? This is your area of integration. So, since it is a vertical strip, it starts from the line and ends at the parabola. So now we have to find the point of intersection. It is as usually we can find it by changing the order of integration. There is the parabola and line. Since there is a parabola and a line in the limit and the feasible region of integration, we will have to draw two horizontal strips. This is a major point here. Where you have to draw two horizontal strips. These two horizontal strips are to be drawn in between these the feasible region here. Here one horizontal strip and here one horizontal strip. Since we have in the region of integration, here we have a line and here we have a parabola. And therefore, we have to draw two horizontal strips as discussed. So this is the figure wherein we have drawn this one horizontal line and this one horizontal line. So now we have to split the area of integration. One part is this one and the other part is this one. So one is triangle part and other one is a sector part. So we will have two area of integration. One is OAB and the other is ABC. What do we now do? We will just find the values using the limits corresponding to the spaces listed. So in the region OAB, what will be the limits? The limits are x is equal to 0 to x is equal to root ay. And what is y limits? Y is equal to 0 to y is equal to a. It is a constant type. Therefore, what is I1? I1 is nothing but double integral OAB, x's limits and y's limits are written and we have found the value. Just a mere simplification will give you the value of I1. In a similar way, in the region ABC, what are the x limits? X limits are x is equal to 0 and x is equal to 2a minus y. What are the y limits? Y is equal to a and y is equal to 2a. How we have found it? We have just found it using the diagram. So it starts here and ends here on the parabola. If it starts here, it is the axis x is equal to 0. If it ends here, it is a parabola x squared is equal to ay. So that is what we have mentioned as the limits of I2. Now, what are the limits of I2? Double integral ABC xy into dx dy, which is equal to integral a to 2a, integral 0 to 2a minus y xy into dx dy. With mere simplification, we will be getting the values of I1 and I2. Now, what is I2? I2 is double integral on the area ABC. We will just calculate it using simple calculations as integral computations, and I2 is found to be 5a power 4 by 24. Now, what do we have to do? We have to add up the two area of integration to get the final value. What is our final value here? Double integral over the region R xy into dx dy is equal to, the first I1 is a power 4, a power 4 by 6, and I2 is 5 a power 4 by 24. On adding up two of the things, you will have I is equal to 9 a power 4 by 24. So this is how we compute the integral values using change of order of integration. This problem is a little bit varying with the diagrammatic representation. So you can notice the concepts infused here. Thank you.